All right, so the concept of inverses and compositions. When you talk about inverses, you're talking about undoing something. Inverse operations. The inverse operation of addition is subtraction, right? Because subtracting a number undoes that number, right? When it's in an equation, things like that. When we talk about inverse, that whole idea of inverse, I try to stay away from the connotation opposite, because sometimes opposite implies positive and negative. Really, we want to focus on the undoing of something, right? So this question is saying, prove that f and g are inverses of one another. If these functions are inverses of one another, then they should undo each other, if you think of it that way. So if I compose them, think about what we're doing. If I compose these two functions, meaning create this composition of f g of x, I'm making g of x the input into this. So all of the operations that I'm doing to x here, if this is in fact the inverse, it's going to undo all of those operations. And then what will I be left with? X. I'll have nothing being done to x, essentially. So that's the bottom line. The bottom line is, if you want to know, and this is if you want to, if you're taking notes at home, for example, if you want to know if two functions are inverses of one another, then their composition should simplify to be just x. So let's see if that is in fact the case. Now it has to work both ways. So in other words, I have to compose g with f, and then I have to compose f with g. So the first one I'll do is I'll take g of x, and I'll make g of x the input into f. So that would look like this. Right? You want it color coded? All right, I'll give it to you color coded then. I'm taking this and I'm making it the input here. Putting it wherever the x is supposed to be. So what am I doing? Let's take a look at, now we're trying to look at this expression and simplify it. So I'm squaring a square root. Squaring a square root, those are inverse operations. They, quote, undo each other, if you will. So I have 9 minus...
Wait, the 9 minus x is just 9 minus x, no x squared.
It's not, oh, this isn't squared? Okay, thank you. So I have 9 minus, this is gone, but I had 9 minus x under here. Yep, that would have made a difference, right? Okay. So I have 9 minus x. That quantity that I squared should stay in parentheses. Why? Because I'm subtracting that quantity. So I want to make sure that I'm subtracting both quantities that are in here. That's why I keep those parentheses around. So this is 9 minus 9. I'm subtracting the 9, and I'm subtracting a negative x. So that's positive x. And 9 minus 9 is 0, leaving me with just x. So the composition of those two functions is x. The square root undid the squaring, and the subtraction undid the 9. Right? You see, I don't even think that's proper English. Undid. I don't know if that's a word, but I'm using it. All right? This is an English class, right? So, if I compose the other way, g of f of x, that means I'm taking this function and using it into the input of g. So 9 minus x squared. So I have the square root of 9 minus x squared. So the 9 minus x squared, once again, is going in for x. This is going here. Keeping parentheses around it, again, because it's two terms, and I want to make sure I subtract both of those values. It's more than just one term. So I end up working inside out. I'm taking what's under the radical, subtracting 9, subtracting negative x, so that looks like this. Excuse me, x squared. 9 minus 9 is 0. So I have the square root of x squared, and the square root of x squared is x. So I get both compositions simplifying to x, therefore I know they are inverses of one another.